Hello student, today in chemistry we discuss about stoichiometric coefficient and what is the importance of stoichiometric coefficient and what information we will get from this stoichiometric coefficient. Before that we have studied about empirical formula and molecular formula. Empirical formula, in short, it is a ratio between the elements in the molecules, smallest ratio, and molecular formula means the molecular mass or molecular weight, complete formula. In stoichiometric coefficient you will get idea about number of reactant or amount of reactant react together in a particular ratio to give product in particular ratio. So from this stoichiometry you can get the idea, or if you want to prepare some product in particular gram, then stoichiometric play important role to find number of product as well as number of reactant required to overcome that product. So today we discuss about stoichiometry. The word stoichiometric is obtained from Greek word. Greek word stoichion. Stoichion means element and metron means measurement. So it is nothing but it is element measurement of elements or amount of element present in a compound can be found with the help of stoichiometry. We take the example combustion of methane. Methane formula CH4, when it reacts with oxygen, exothermic reaction takes place or burning of methane will take place and it is converted to carbon dioxide and water. If you balance the reaction, then you can say 1 mole of methane react with 2 mole of oxygen to give 1 mole of carbon dioxide and 2 mole of water plus heat energy. So that is known as stoichiometry. You can get the idea. Reactant. Okay, I have written reactant 1 mole methane. Second reactant is 2 mole of oxygen gas, O2 gas. In product side, 1 mole of carbon dioxide is produced and 2 mole of water is produced. Now we compare mole with molecular weights and number of molecules and its volume. So 1 mole is equal to gram molecular weight. 1 mole is equal to gram molecular weight of that particular substance. If it is 1 mole of methane, CH4, carbon 12, hydrogen total 4, so 12 plus 4, 16. So 1 mole of methane is equal to 16 gram. Similarly, oxygen O2, so it is 32. The number of oxygen is 8, weight is 16. O2, 16 and 16, so it is 32. So 1 mole of oxygen is equal to 32 gram, but here it is 2 mole, so 64 gram. So 12 gram. 12 carbon 12 plus 4, so 16 gram of methane react with 64 gram of oxygen to produce CO2, carbon 12, oxygen 16 and 16, 32, so it is 32 and 12, 44, and water, molecular weight is 18 and here it is 2, so it is 36. So in terms of gram, if you calculate, then this reaction says that if you take 16 gram of methane, then 64 gram of oxygen will react. This is required to give 44 grams of carbon dioxide and 36 gram of water. So here 1 mole is equal to molecular weight. 1 mole is equal to 22.4 liter volume at STP. STP, standard temperature and pressure. So in terms of volume you have to find. If gases are produced and temperature and pressure is at STP, then 1 mole is equal to 22.4 liters. So here 1 mole 22.4 liter, here 2 moles, so 2 into 22.4 liter, it will produce 1 mole means 22.4 liter of carbon dioxide and 2 mole of water. So it is 44.8 liter of water will produce. Last thing, from stoichiometry we will get about molecules, number of molecules. 1 mole is equal to Avogadro's number. Scientists Avogadro discovered that 1 mole having Avogadro's number of molecules. That value is 6.022 into 10 raised to 23 molecules. So 1 mole is equal to this much molecules. Again 1 mole of methane, this much molecules of methane, this much molecules of methane react with 2 mole of oxygen, means double of that. That will give 1 mole Avogadro's number of CO2 and 2 mole means this much molecules of water. This into 2 moles means what? Avogadro's number into 2. This much molecules of water will produce. Okay, now we take one example how to find particular gram of product is obtained, or how to find how many grams of reactant we have to take to get this much amount of product. So one by one we discuss 2 examples of reactant and product. Okay, first example, problem number 1.3 of your exercise. Okay, from your textbook 1.3. Calculate the amount of water in gram produced by combustion of 16 gram of methane. So combustion of methane is taking place and you have to find what is the amount of water produced in gram. So first we will write the reaction, then try to balance reaction, find the stoichiometry, how much mole of reactant and how much mole of product is produced, and from that we can find the grams of water. So I am writing the first reaction, methane, combustion of methane. Methane means formula is, okay, alkene says methane CH4 in gaseous state. This, when it is burned in the presence of oxygen, it is converted to CO2 plus water. Carbon dioxide plus water is produced. If you try to balance it, first carbon is same, here 1, here 1. Okay, hydrogen here it is 4, there it is 2. So first we balance hydrogen. So 2 mole of water is produced. Now we balance oxygen. On reactant side 2 oxygen, on product side this 2 and 2, 4 oxygen. So here we will write 2. So stoichiometry is 1 mole. 1 mole of methane react with 2 mole of oxygen to give 1 mole of carbon dioxide and 2 mole of water. So this information we are getting when we balance the reaction. Now on to our point. Calculate the amount of water in gram produced by combustion of 16 gram methane. 16 gram methane. 16 gram is. Now if gram is given, you convert into mole. Mole is equal to weight upon molecular weight. Weight we have taken 16 gram. Its molecular weight of methane. Carbon is 12, hydrogen 1, but total is 4. So 12 plus 4, 16. So answer is coming 1 mole. So 1 mole of methane is burnt, means 16 gram. Then question is how many grams of water is burnt. So 1 mole is burnt, then 2 mole. 1 mole methane is equivalent to 2 mole water. 2 moles of water. Now in terms of gram we have to find how many grams. So mole is equal to weight upon molecular weight. We want to find the weight in grams. So weight is equal to mole into molecular weight. Mole, 2 mole is produced, and molecular weight of water is oxygen 16 and 2 hydrogen, H2O, 2 plus 16, so it is 18. So total 36 gram of H2O is produced. So answer is, if you take 16 gram of methane, means 1 mole, then 36 gram of water is produced. Okay, in terms of molecules also you can find 1 mole of methane is 1 mole, so Avogadro's number 6.022 into 10 raised to 23 molecules of methane gives 2 molecules of water, 2 mole of water. So in terms of molecules, Avogadro's number multiplied by 2, so it is 6 multiplied by 2, so 12 point something multiplied by 10 raised to 23 molecules of water will be produced. Okay, second example we take problem number 1.4 of your book. How many moles of methane is required to produce 22 gram of CO2 after combustion? The question is how many moles of methane? And methane combustion, again we write the reaction. Methane CH4 on combustion means react with oxygen. It will produce carbon dioxide plus water, 2 mole of water and 2 mole of oxygen is given. Here reverse thing is given. Gram is given, gram of CO2 is given, means what? We want to produce this much gram of CO2, 22 gram of CO2. First we convert whatever gram into moles. Mole of CO2 is equal to weight of CO2 upon molecular weight of CO2. So we will find moles of CO2. Weight is given, we want to produce 22. Molecular mass or molecular weight of CO2, that can be calculated by molecular mass means what? Carbon is 12, oxygen 16, to 16 plus 16. So total it is coming 44. So molecular mass of CO2 is coming 44, 22 by 44, so it is coming 0.5. Okay, so we want to produce 22 gram is equal to 22 gram. In terms of gram it is 22 and in terms of mole it is 0.5 mole, means half mole. Question is how many moles of methane is required. From stoichiometry we get the idea. Here it is 1, so 1 mole gives react with 2 mole of oxygen, gives 1 mole of carbon dioxide and 2 mole of water. Now we want to produce half mole and we want to get the idea how many moles of this. So here from the stoichiometry, 1 mole of CO2 is equal to 1 mole of methane. But here we want to produce 22 gram or half mole. So 0.5 mole of CO2 is equal to 0.5 mole of methane. Okay. So stoichiometry is 1:1. Number of mole of CO2 produced is directly proportional to number of methane required. So here 0.5, but if you want to convert into grams, Mole is what? 0.5 mole of methane is required. Answer is coming. But we want to find how many grams of methane is required to produce 22 grams. So here, if you want to find the grams of CO2, then is equal to mole multiplied by molecular weight of that particular substance. Mole is 0.5 multiplied by molecular weight of methane. Carbon 12 and hydrogen total 4. So it is 16. So 16 into 0.5. So it is 8 grams. So for producing 22 gram of CO2 means 0.5 mole, we require 0.5 mole of methane or 8 gram of methane is produced. Here I have written wrong methane, molecular weight of methane. So it is 1 gram of methane. How many grams of methane is required or mole? Mole then it is 0.5 and gram is 8 grams. So in this way we find what will be the product or what will be the reactant required to overcome that product or to prepare that product. Okay, try to solve this sums, problem number 1.3 and 1.4. That is based upon stoichiometry. Okay, second topic is limiting reagent. In stoichiometry, limiting reagents means that component of reactant which limits the product. We take the example, from that we can find the limiting reagent. Suppose nitrogen react with hydrogen and it will produce ammonia, NH3. If you balance the reaction, 1 mole of nitrogen react with 3 mole of hydrogen to give 2 mole of ammonia. Okay? This process is known as Haber process and pressure is required. Reactant are in gaseous form, so if you apply pressure and catalyst, then it is converted into product. Limiting reagent means the lesser amount of reagent which will limits the product. Okay, suppose here ratio is 1:3, 1 mole of nitrogen react with 3 mole of hydrogen to produce this. But out of these two components, if the amount of one of the reagent is less, suppose we take nitrogen in less gram, only 0.1 gram, then the product obtained will be very less, or it is directly proportional to this nitrogen. Okay, nitrogen if it is less in the reactant, then product will be less. Similarly, if vice versa, if you take hydrogen less in proportion, stoichiometry is there, but if hydrogen during the mixture, if you take hydrogen in less proportion and nitrogen in excess proportion, okay, here you take 1 gram of hydrogen and here in excess, okay, 1 kg or 1000 gram of nitrogen taken, you take 1 gram of hydrogen, then this hydrogen is a limiting reagent. It limits the product which is obtained, it will limits the product. Well, problem number 1.5 is related with that only. Whatever thing is given, so in homework try to find limiting reagent. Okay, problem number 1.5 of your textbooks. Try to solve it. How to solve it? First, you find the moles. Gram is given of this reactant. From that gram, find the moles, and you compare the moles. The amount which is in excess as compared to other element. That excess element will not affect the product. But the minor thing means lesser amount of the reactant will decide the product. So that reactant component is known as limiting reagent. Okay? So you revise properly and any doubt then you ask me. Okay? Thank you.